my dear student, I'm Sakitwala from Educators. I will be with you in physics for Form 5. And today, my dear student, we are going to proceed with our discussion on our topic of the fluid dynamics for the new subtopic, which is called viscosity and turbulent flow. This is what we are going to discuss for our today discussion here. So let us go and start our new subtopic, which is called the viscosity and the turbulent flow. So this, my dear student, is not a new term for you. Viscosity. Viscosity, we have tried to say that this is the types of the fluid which contain the internal friction. It means that the internal friction are exact between the layer of the fluid. This is how we can explain about the viscosity, my lovely students. As we see our statement here, say that this section introduces the concept of viscosity in fluid. Now, on this subtopic, we are going to see the concept of the viscosity in the fluid. Kwamba how the viscosity can occur in the fluid. How the viscosity give us more explanation. This is what we are going to see on this subtopic. So viscosity explain it as internal friction that convert the kinetic energy into the internal energy. Because the way we know about the viscosity, we define the viscosity as the internal friction that exists between the layer of the fluid and convert the kinetic energy into the internal energy. Kwa hii ndo definition nzima ya ile viscosity, the way we can explain as the internal friction that occur between the layer of the fluid and can convert the kinetic energy into the internal energy. So it contrasts this with the previous discussed ideal fluid and outlining the topic of the covered. So Newton law of viscosity and the Pistorius formula and Stokes law. On this, my dear student, we will try to look only at three laws. There are three laws that can occur on our subtopic here. Ya kwanza tutaenda kuangalia huyu tunamuita ni Newton law of viscosity. Tutaenda kuangalia sana formula yake inasemaje. How can we derive that formula? How my dear student can explain that law. This is what we are going to see the relationship, the force and also the distance on the viscosity law. Also, we should go and observe about the Poisson formula. Kwenye Poisson formula, we are going to see the pressure density. Ndio vitu ambavyo tutaenda kuviangalia huku. Law ambayo inakuwa inaelezea uhusiano uliopo kati ya distance pamoja na pressure na vitu vingine vile. That is what we are going to see on the Poisson law. While on the Stokes law, we are going to see the volume flow rate. This we are going to see the volume flow rate. The relationship between the volume and also, my dear student, and also the distance or the radius. Sometimes we can term it. So let's start with the coefficient of viscosity. How can we determine the coefficient of viscosity? What is the coefficient of viscosity? That is what we are going to try to explain on our discussion here. Coefficient of viscosity is represented by this symbol, coefficient of viscosity of the fluid. So we express it by using this symbol, my dear students. So by definition, we can define by saying that this is a measure of the degree to which the fluid exhibits the viscous effect. Kwa hiki ni kifaa ambao kinakuwa kinatumika kwamba the measure, this is the measure of degree to which the fluid exhibits the viscous effect. Kwa hiyo tuweze kudetermine the effect of viscosity in the fluid, we should use the coefficient of viscosity of the fluid. Kwa hiyo uweze kudetermine sasa kuna effect gani mle kwenye ile fluid. It means kwenye ile fluid kuna effect gani, we should use the coefficient of the fluid. now we should go and see, my dear student, how can we obtain the coefficient of viscosity of the fluid using the formula. So this effect is described by using the Newton law of viscosity. So we identify the effect of viscosity, as we have told you, on the coefficient of viscosity of a fluid. We identify using the Newton law of the viscosity, which states that friction force F between the layer is direct proportional to the area of the layer and also the velocity gradient. Kwa tuna state hii law yetu kwa kumwambia kwamba ile friction force ambayo ita exist between the layer of the fluid must be directly proportional to the cross section area, and the velocity of the gradient. Tutaenda kuangalia velocity of the gradient. It means we take derivative of the velocity with respect to the distance. This is the velocity gradient dv dy. So this is how we can state the Newton law of viscosity. Kuna maswali mengi sana ambayo utakutana na kuambia kwamba elezea ni namna gani hii viscosity inaelezea, kwamba can you explain the concept of the viscosity. Mwambie viscosity, this is the internal friction that exists between the layer of the fluid, and it can be used to convert the kinetic energy into the internal energy. And also tamwambia utaulizwa how can we state the Newton law of viscosity. So if you really ask it to state the Newton law of viscosity, utamwambia this law state that the frictional force F between the layer of the fluid is direct proportional to the cross section area, and the velocity gradient dv dy. This is how we can state our law. So consider a pipe that contain a fluid flowing as steadily as it shown on your figure. Sasa tujaribu kuangalia figure yetu ambayo inside the figure here we have the pipe, and this pipe having or containing the fluid flowing as steadily. Kwa hiyo tuna pipe yetu, hii pipe ina liquid na kimiminika humo ndani, na kile kimiminika kinajaribu kuflow as we try to see, my lovely student. Inside of the figure, as we observe here, we have a different points. We have the point O, point B, and the point C, and also this point B. Kwa kwenye point B hapa, fluid ambayo ina flow hapa must be the same with the fluid that is flowing at this point, because at the same point, kwa sababu ni pointi ambazo zinafanana. This is the direction of the fluid. The fluid flow, my dear student, from this axis here toward the velocity 1, as we try to observe here. Kwa ndo direction kwamba speed itaanzia upande wa kushoto itaelekea upande wa kulia, lakini kwenye upande wa kushoto hapa tunakuwa na speed 2 pamoja na speed 1. Tunakuwa na speed 2 also we should have with v. This is the constant velocity as we observe here. But on this on the right side we have the speed ambao ni v1. So this figure here explain the friction between the successive layer of a fluid. Kwa ni figure ambao inaelezea ile friction between the successive layer of the fluid. So my lovely student, here let us proceed as we observe that. Let's see the statement that explain about our figure here. So there are so many cylindrical fluid layer located at a different position within the pipe. Kwa kuna cylindrical tofauti ambazo zina exist between that is located katika position ya ile pipe yetu. We should have the different cylindrical that could exist on our figure here. So layer have varying speed ranging from 0 at the wall of the pipe to the maximum speed at the center at the center of the pipe. So fluid layer between C and B have the velocity which are less than that of C, but they greater than at this one. Kwa tukiangalia ile figure yetu, my dear student, we observe that this at the fluid layer at point C and also at point B having the having the speed which is less than that at the point than that at the point P. Kwa pale tunakuwa tuna observe kabisa kwamba speed iliyopo hapa kwenye point huyu B pamoja na C ni ndogo sana ukilinganisha na ile speed iliyopo at the point P, as we try to observe. That is what we have been told on our explanation here. So my dear student, if A is the surface area, kama A atarepresent the surface area of the layer of contact. Now V1 are divided V1 minus V2 because at the point because at the right hand side we have the highest speed. Kwa tutachukua yule V1 tutamtoa na yule V2. Kwa kama yule A anarepresent the surface area of the layer in the contact. Now V1 minus V2 divided by H is called the velocity gradient. Ambao tulisema ni sasa na dy divided by dv divided by dy. But dv here must be equals to the v1 minus v2, lakini dy atakuwa ni sawasawa na h, as we try to observe, where this must represent v1 the ratio of v1 minus v2 and also the h which could be the velocity gradient, lakini yule h atakuwa ni ile distance of the separation of the two layers with the velocity v1 and v2. Kwa hiyo atakuwa ni height of separation, itakuwa ni height of separation, as we try to see this must be the height of separation here. Now my dear student, then according to the Newton law of viscosity, let us go and recall the Newton law of viscosity, as we know how we can represent it.